All right, guys, this is for pre-cal and for cal. This both lands in 1.5. If you're in pre-cal, this is the chapter at the end of the school year when we are starting to learn some calculus. So this last section for limits is about infinite limits, like saying limit to infinity, and when a limit will equal going towards infinity. So the most important thing I can tell you about this section is to know your graphs. If you don't know your graphs, this is going to be pretty difficult. If you do, this ends up being pretty easy. So the graph of 1 over x squared, if you've taken my class, we've memorized that both of these scenarios are elbows, okay? When the exponent in the denominator is even, both elbows are on top. So I have something that looks like this. And the reason why these make these sort of elbows is because they have asymptotes, like a T, right? And then the moment I start having transformations, these asymptotes will move with it. Okay? Now, 1 over x has elbows, but on opposite corners. And again, they also have the same asymptotes going on. So if we use the method we were talking about in the previous lesson about checking them from the left and from the right, I obviously see that at 0 I have a discontinuity. So if I try and plug 0 in here, I'm going to get 1 over 0, which is undefined. So I can't just solve this one by plugging in 0. I have to start analyzing the graph and see what's happening from the left and from the right. So I can say that the limit as x approaches 0 from the right, as I come from the right, I shoot up towards positive infinity. Now, analyze it from the left. From the left, as I approach 0, I also shoot up towards positive infinity. So this was one of those discrepancies that I told you some textbooks say that because infinity is in an actual location, it does not exist. And some textbooks will say, well, since they're both going to infinity, from the left and the right, they're going to the same place. So the limit is indeed going to infinity. You'll see that some textbooks say does not exist, and you'll see some that say infinity. I like to hang on the side of infinity, but both are correct answers. If you plan on taking AP in the future, they are well aware of this, so they'll make sure never to put both of these options in a multiple choice. I like the habit of you writing both so that you make sure you catch it anytime, okay? So let's look at this one. If I check this limit as I approach 0 from the right side, as I get closer to 0, this function shoots upward to positive infinity. If I check 0 from the left, well, 0's here, and the function on the left is down here. And as I get closer to 0, I start to shoot downward towards negative infinity. So because from the left and from the right, they're not going to the same location, this is a clear cut, does not exist. So you're going to see a lot of the questions today are going to be writing along asymptotes, whether they are horizontal or vertical. So that's why we said at the beginning that knowing your graphs is super important, because if you can figure out where those asymptotes are for these next few questions that start getting a little more complicated, it's going to become a lot easier. All right, so these next two questions, we're going to some transcendental functions. And again, that's just a fancy word that takes into account logarithmics, exponentials, and trig functions. So the limit as x approaches 0 of ln of x. So it's funny because if you put 0 into ln of x in your calculator, you're going to get an error. So let's analyze this. Okay, the graph of ln of x shoots out on the right side with an asymptote at 0. Okay, so if I analyze both sides, if I approach 0 from the right-hand side, so here's my function, and as I start getting closer to 0, this starts going down with an arrow, which means infinitely. So this goes down to negative infinity from the right side. the limit as x approaches 0 from the left, well, the fact that from the left of 0 I don't have any function to even analyze automatically means that nothing exists on that left side. Okay? So for that reason, the limit as x approaches 0 of ln of x, again, from the left and the right, didn't go to the same place, does not exist. But do take into account, guys, that the single question on like quiz, test, and the AP could just be this one. They could ask you the limit as x approaches 0 from the right of ln of x, and then I could give a clear-cut answer. Okay? So the graph of e to the x, okay, is the exponential function with the asymptote horizontally at 0. Now, here's probably the first time we're putting an infinity in the spot of the x. So it says the limit as x approaches negative infinity. Well, a negative infinity on my x's means going forever towards the left, okay? So if I continue on this function to go towards the left forever, what y will I forever get closer to? And hopefully you see and you understand the concept of asymptotes, that this will only ever approach the asymptote. What is the location of the asymptote? The location of that asymptote is 0. Okay? So whenever you have infinities in the spots of the x, your answer almost always, if there is one, is going to be that horizontal asymptote. Okay? And that goes again back to why knowing these graphs are so important. All right, so our next two questions. We have the limit as x approaches pi over 2 of tangent of x. Okay? So our graph for tangent looks like the x cubed graph, but has asymptotes over here at negative pi over 2 and over here at positive pi over 2. Okay? So these are things you should have in the back burner from pre-cal. If not, remember I have a formula sheet with all of these trig functions. You can also go back to the video that's taught in trig and in pre-cal to remember what these graphs look like. So if I analyze the limit as x approaches pi over 2 from the right of tangent. So pi over 2 is here. From the right, I at the moment don't see anything happening. Remember that every single trig function happens infinitely. So what I drew here was just one cycle. This exact thing happens again and again and again, both to the right and both to the left. So that means if I analyze this side, I should have another x cubed graph and another set of asymptotes and so on. So if I look at pi over 2 from the right side, my function goes downwards to negative infinity. Okay? Now, my limit as x approaches pi over 2 from the left, well, from the left side of pi over 2, my function shoots up towards positive infinity. Okay? So this is another scenario that from the left and from the right, I'm going in two different directions. So the limit as x approaches pi over 2 of tangent does not exist. And again, don't be surprised if the only question you have on a homework quiz or test is just one of these and not necessarily all three, okay? So now cosecant. Cosecant is the flip-flop graph of sine, okay? So this graph, remember I would have had like a sine graph, probably having some flashbacks of when we learned this. Every time I hit the midline, I have an asymptote. Okay? And then my actual function bounces right here. Okay? So if I'm analyzing 0, and hopefully you get to the point that you don't have to break this down every single time. As I approach 0 from the right side, my function shoots up to infinity. Now again, like what happened here with the tangent, I don't necessarily have drawn what happens on the left, but if you understand the behavior, this will keep going down and back up. Okay? And then I'll have another one down here. So just follow the pattern of that wave, and the opposite thing will keep happening. Okay? So as I approach 0 from the right-hand side, I shoot up. And as I approach 0 from the left-hand side, I have a function that shoots down. So from the right goes to positive infinity, from the left goes to negative infinity. Two different spots, therefore the limit at 0 does not exist. Let me write that a little slower. So as I approach 0 from the right, we said it went up to positive infinity. From the left, I go downwards to negative infinity. And since they're two different locations, does not exist. Okay? So we saw basic rational functions at the beginning. We saw exponential and log. And now we saw trig. Let's start seeing what happens when these polynomials and rational functions start getting a little more complicated. All right, for these next questions, our rational functions are going to start to get a little more complicated. So the most important thing to remember is where our asymptotes come from. A reminder of our rules, and if you haven't watched the previous video, make sure to do so, that when my denominator equals 0, that is where I get a vertical asymptote. So if I set x minus 3 equal to 0, I get that x equals 3, and this is my vertical asymptote. Okay? And then the next rule was comparing the highest exponent in numerator and denominator. So if I have 2x over x, the exponents are the same, therefore 2 over 1, which is 2, is my horizontal asymptote. Okay? And again, that's on the y. Now, the limit says to only look at 3 from the right-hand side, so I really only care what's happening over here. So in order to understand what's happening there, it'd be easy to plug in one simple point after 3 to see whether the function is an elbow down here, shooting down to negative infinity, or an elbow up here, shooting up to positive infinity. So just plug in 4, and I get 2 times 4 plus 1 in my numerator, which is going to be 9. And then in my denominator, I'd get 4 minus 3, which is 1. So at 4, I'm at 9. If this is 2, 9 is somewhere all the way up here, which means my elbow is in the top corner, not the bottom. And if it's in the top corner, that means from the right side of 3, I shoot up towards positive infinity. This section is really all about knowing your graphs, guys. So, I mean, I'm not even going to waste my time figuring out the left side of this graph. If I needed to, I could just plug in any point to the left of 3. But I would only need to do that if they asked me about the limit as x approached 3 from the left. All right, let's look at our next one. So I'm going to start off with the same concept. I know fraction functions, rational functions, have horizontal and vertical asymptotes. Okay, so again, denominator set equal to 0. Please don't forget that every square root that you do has a plus or minus. Makes a big difference, okay? You'll miss an entire asymptote. Okay? And this is my vertical asymptote. horizontal, I'm comparing my highest exponents. So I have an x squared over an x squared. My coefficients are 1. This is where my horizontal asymptote is. Okay. And then this limit is asking me about approaching 1 from the left. So if positive 1 is here and I want to know 1 from the left, I only care about this middle portion. Okay, if I jump over here, I'm too far. I just care about as I get closer to 1 from the left, which is just this area. So in this area, I want to pick an easy number to plug into a function to find out whether it's happening down here, shooting downward, or up here, shooting upward. Remember, the function will fit into asymptotes like elbows. So this one will almost be like a whole U going down or a whole U going up. So easiest number in here is 0. So if I see my function at 0, I get 0 squared plus 1 over 0 squared minus 1, which gives me a negative 1. So if my point is down here at negative 1, remember I can't go upward towards the asymptote, so this has to shoot downward. Okay? And again, I could take time to find what the function looks like on the other sides. There should be 3 sections of this function. But since I only care about 1 from the left, I only care about what's happening as I get closer to 1 from the left, and this shoots down to negative infinity. All right, so for this next part, it's about bottom heavy and top heavy. This is kind of like a nickname that was given to this. This is when I'm finding limits that are approaching specifically a positive or negative infinity. Now, this is a nice shortcut as opposed to having to graph, but again, this only works with infinities. Okay, so bear with me. I never expected to have to be teaching you these silly rules through a video, so I'm sure you can imagine me blushing and laughing at myself if we were in person. So when I plug in infinities into fractions, the infinity can land on the top. The infinities can land on the bottom, or if there's a variable in both numerator and denominator, the infinities can land in both spots. So again, when I teach this in class, I probably look like a fool making these jokes. So please don't go telling your parents that you have a crazy teacher on YouTube. But I always use the fraction as a body to help you remember. So particularly a female body, if we're going to call this infinity weighs a lot, right? It has the most weight. So we're going to call when the infinity lands on top, top heavy, and when the infinity lands on bottom, bottom heavy. All right? So if you can imagine, a woman that is top heavy usually has bigger, and you can imagine what that looks like. Okay? And a woman that is bottom heavy usually has a big O. Yeah? So again, you can imagine how this usually goes when we're in class. We have a few laughs. But top heavy fractions, whenever the infinity lands on the top, it equals infinity. And if the infinity lands on the bottom, it is bottom heavy, and we call that equaling 0. All right, so when the infinities land on both, there's no joke for this one. You use the horizontal asymptote rule, okay? And if you remember in the horizontal asymptote rule, I kind of refreshed it for you here. Whenever the exponents are the same, meaning the infinities will weigh the same, then we said we would use A over B, okay? Now, the only thing that changes a little bit is if I plug in negative infinities. So negative infinities has a little extra detail, and this will all start to hopefully make a little more sense once you start seeing the questions. But if it is equal, meaning let's say you plug in an infinity into an x squared and into an x squared, now the weight is evenly distributed, so I have to go to my horizontal asymptote rule. If I plug in positive infinities, you could just use the A over B, whatever the coefficients were, okay? But if I plug in a negative infinity, if those exponents were even, then I still just use the positive A over B. But if the exponents were odd, let's say it was an x cubed and an x cubed, then I need to take the negative that I used for the infinity and include it in my answer. Now, again, this might sound a little like arbitrary as I'm going through the rules, but as you start seeing the problems, hopefully this makes a lot more sense. So let's check it out. So this first question, the limit as x approaches negative infinity. If I were to plug in an infinity, it would only go into the bottom, and I'd have 4 over one of the infinities. Doesn't matter if it's negative or positive here. If it's in the bottom, it is bottom heavy, so my answer is 0. Yes, it is as simple as that. This is not a trick. Okay? Now, let's look at this one. I plug in infinity here. I have a number, whether it's positive or negative. A number over an infinity is also 0. Okay? I swear I'm not tricking you. Now, this next one has a little bit of an extra step just because I have 2 things here. Okay? I have the 2 and then I have the fraction. So remember that on limits that are separated by addition or subtraction, I need to take each of them into account separately. So if I were to do the limit as x approaches infinity of 2, this is a constant. And the limit of any constant is just that constant. So the answer to this first part is just 2. There's no fraction there. There's no variables for me to plug in an infinity. Plus, if I do 3 over and then I plug in the infinity, okay, this portion here is bottom heavy, okay, because the infinity lands in the bottom. And bottom heavies equals 0. So what I'm really working with is 2 plus 0, which is just 2. Okay? All right, let's start looking at these next ones that look a little more complicated. I'm plugging in an infinity. When I have multiple terms in numerator and denominator, I only care about looking at the term with the highest exponent. So I have a positive 3x squared, and I have a positive x squared. Okay? So I am plugging an infinity into both of them. Okay? Now, if I want to analyze top heavy, bottom heavy, or equal, I need to look at the exponents. Both of these exponents are 2's, which means they're equal. They both have equal weight. So if they both have equal weight, I'm going to use a horizontal asymptote rule. I'm just plugging in a positive infinity. So my answer is my coefficients, which is 3 over 1, which is just 3. Okay? Let's look at the next one. Highest term in the numerator, highest term in the denominator. Okay? Now, when I look at these two, again, a 3 and a 3, this is equal. If one of these were bigger than the other, I'd be back to either top or bottom heavy. Okay? And we'll see that in a moment. So since they're the same, I'm going to use the coefficients. But I'm plugging in a negative infinity. So I have to see, are those exponents that are equal, the 3's, are they even or odd? Because 3 is an odd number, I need to keep that negative from my negative infinity. So it'd be negative 4 over 2, which is just negative 2. Okay? For the next one, highest exponent on the top, highest exponent on the bottom. When I compare these exponents, I have a 3 on the top and a 2 on the bottom. These are not equal in weight. 3 as an exponent is worth more than 2. The 3 is on the top, so this is a top heavy question. So this one equals infinity. All right. Last one. Highest exponent in the numerator, highest exponent in the denominator. And don't always expect them to be the first term. They might try and trick you and switch that around. They're mean like that sometimes. So a 4 and a 4, this is equal in weight. So I'm comparing my coefficients, which is 8 over 2. Okay? Now I'm plugging in a negative infinity. So I have to check as to whether those exponents were even or odd. Because they were even, I can keep this as a positive a over b, and I do not have to plug in that negative. Only if those exponents were odd, like this one up here. So 8 over 2 is just 4. All right, for the last part of this video, we're going to look at this section from your homework. It's from a textbook. Specifically, it is the Sullivan Calculus textbook. And it is the homework section for 1.5. Okay? So I'm going to look at this graph. You guys have the odds for homework, and we're going to look at the evens. Okay? So a lot of times in calculus, they like to show you an image, and you have to be able to figure out on your own, okay, what the limits are. So if they tell you that this image represents f of x, okay, it says find the limit as x approaches negative infinity of f of x. So if I'm looking at the point that shoots out most to negative infinity on the x, that means I'm looking most to the left, okay? Which of these sections is most to the left? Well, this is the furthest to the left. Now, as this shoots out to the left, what is this approaching on the y? And hopefully you can see that this is an elbow that is riding along the x-axis, which is y equals 0. So, as I shoot out to the left on the x, on the y, it will only ever approach 0. Okay? Let's look at the next one. As I approach -3 from the right, well, -3 is right here. Okay? This is the left side, and this is the right side. So as I approach -3 from the right side, I'm looking at this part of the function, and it shoots straight down to negative infinity. All right, the next one says the limit as x approaches 0, here is 0, from the right side only. Okay, right side is here, anything in this section, which I have this parabola facing upward. So as I start getting closer and closer and closer to 0 on the right side, this is shooting up to positive infinity. And the last one, as I approach 4 from the right-hand side, I am going up forever. Okay? So a good rule of thumb for you to remember is that up forever is positive infinity, down forever is negative infinity, right forever on the x is positive infinity, and left forever on the x is negative infinity. Okay?